Wait, is 62 a multiple of 3?
Oh, no. It should be 61. No, wait a minute. 60. Let's make it 60. How about? Sorry about that. All right.
I'm like really confused.
It's obviously a factor of 3.
Okay. So, I was going to write down Chapter 1 test Thursday, which is the 31st. All right. And then I sort of like planned out the rest of the semester.
Really?
Yeah.
Over the weekend?
Like an hour ago.
Wow.
Um,
It only took you an hour?
well, no, it took 3 hours.
Okay.
But it looks like we're gonna do pretty good. I was worried, but that we're gonna do a lot of like skipping of things in the next 4 chapters because I don't know. There are sections where it's like, really, you're giving that its own section? Huh? Weird. So we're going to get through quite a lot. I'm quite pleased. I was a little nervous with the fact that we're just finishing chapter 1 now.
We're supposed to be farther ahead.
But, well, I mean, there's no supposed to because this is the first time. So, you know, you guys are the guinea pigs, right? So, yeah. So we will get, we might get through chapter 6, but, meaning 2, 3, 4, 5, and 6, all in the next like 20 days. It's pretty crazy. But they turn out to be pretty short chapters. And we're going to skip sections here and there, which works out pretty good.
Yeah, are we taking a test for each chapter?
No, so some of them are combined. Yeah, like 2 and 3 are going to be combo unit. Yeah, and then, which is good because I was a little nervous because we have to get trig in, but I think we'll be just fine. So, pretty good. Yes, Jacob. No, I can do it in a quarter. And so that's the plan, is to do trig for 1 quarter. But we'll do, yeah, well, it'll be interesting to see what I decide to end up doing. Yeah. Trig is neat. I really, really enjoy trig. So it's really, really good. Absolute value. What's the absolute value of -9? 9. Okay. So when we have an absolute value equation, well, does anyone know what absolute value actually means?
Distance from 0.
Holy crap! No one ever knows that. You guys are amazing. Yeah. So. Yeah, it's the distance from 0.
It's
I am totally impressed. Okay. Absolute value represents a distance, and technically when we're evaluating absolute value, it represents the distance from 0. So because distances are always positive lengths, positive distances, that makes sense that we can't have a negative distance. It just doesn't really work out. But this is algebra land, not geometry land, okay, where, hey, we have to be able to analyze things for things that are in reality, that'd be the geometry, but also things that are in theory, which is the algebra, okay? So when we're asking a question like the absolute value of what number equals 9, what number has a distance from 0 of 9? 9 and -9. There are 2 values that have a distance of 9 units away from 0. So this is something we have to remember for the algebra part. I've heard so many students that are like, we did this in like 7th grade, and I'm like, yeah? What'd your teacher tell you? They're like, just drop the absolute value, and I'm like, ugh. You can't just drop the absolute value and solve it like normal because there's more than one answer, okay? So we have to think about, I'm glad you remembered that absolute value means the distance away from 0. And so we need to remember now that that distance could have been to the right, yeah, but it also could have been units to the left. And we have to take that into account. All right. So example 1. There are many different ways to do this.
All right, that's a lot of answers.
And so I'm going to show you the way that I like the best. And that is referencing, well, it could have been a distance to the right, or it could have been a distance to the left. So example 1, solve each equation. Letter A is just a rule, actually. So what do we do if we want to find the absolute value of a number that's equal to k? And k represents any constant, any number we can think of, provided k is greater than 0. What does that mean?
It's positive.
Yeah, k is positive, okay? Can the absolute value of a number equal -7? No, why not?
Because negative distances don't exist.
Yeah, because distances, we can't, that absolute value of a number has to be positive, all right? That is a no-go, no solution. We can't do that, okay? So as long as k is positive, then the way I like to think about this is that, no, it could be a decimal. Oh, you're overthinking. Yeah. So this was just information about k. K has to be positive, first of all. Rule number 1, that value must be positive. Okay. But then we also can set up, to solve it, this number, I don't know what it is, that number, this value k could have represented a distance to the right of 0. Which means if that distance was a number to the right of 0, like this one. Okay, sorry. Sometimes I get off for enough. The absolute value of some number equals 9. 9 is a distance from 0. If we're going to the right of 0, what's that value for x going to be? If we're going to the right, what's our answer? 9. Mm-hmm. But this distance could have been a number, or the 9 could represent the distance to the left. Which means that would have to be the distance to the left is -9. Okay. That's just not going the way I was hoping it would. X equals k, but also it is -k. Yes, I'm trying to. This is not how I wanted to explain this, but
Are we solving for x or k?
x,
K just represents
any
constant.
number like 7 or 12 or 52. I'm sorry. What's the absolute value of 12? 12. Okay. So the inside could have been positive, and it would just equal itself, right?
Yes.
Okay. What's the absolute value of -9?
9.
9. Okay. The inside could have been negative. It's always going to come out positive, right? Okay. All right. So that's how I like to think about it. This inside value could have been a positive number, but it also could have been a negative value. And it would come out as the positive k. How do you get x by itself? Divide by the negative. Mm-hmm. Okay. All right. I'm sorry. I shouldn't have started with a k. Bottom line, there are 2 equations for every absolute value. One that where the inside was positive, and one where the inside could have been negative. Okay? All right?
When it says k is greater than 0, it doesn't matter if x is a negative because it's eventually going to be positive and above 0.
We'll solve for x.
Okay,
Yes.
I know what you're saying.
Okay.
You're showing us how to get to
Yes. Okay. So here we have an equation, an absolute value equation. Bottom line, there are two equations, okay? One equation, the positive equation, where the inside was just what it appears, that positive 2x minus 3, and gave us that distance of 14. The negative equation, because we could have gone the other direction. We could have gone left of 0. The inside could have been negative. And by nature of the absolute value, it cleans itself up to turn out to be positive 14. I always do it this way, where there's a positive and a negative equation. The positive equation is easy. It didn't, positive isn't going to affect our equation, is it?
No.
But what do I have to do with the negative? Well, there's a couple of things we could do. We could distribute the negative. We could also divide the negative, and I'm going to divide the negative. I'm going to divide by -1, and you'll notice what happens to our equation.
It flops.
It's negative 14. So we get that positive 14, and we also get that negative 14.
So you're saying, is this just showing the process, but you're
Yes.
going to say, just do it in your head?
You can do it in your head, yes. All right? But then you get to ones like C, which kind of screw
Right.
everything up. All right. So I'm going to solve for x. I'm going to add 3 and add 3. So we get 17, and then I can divide by 2, so we get 17 halves for one answer. And then same thing here, I'm going to go ahead and add 3, but we're going to get an entirely different answer. Negative 14 plus 3 is negative 11, and then divide by 2, we get negative 11 halves. All right, so that was so terrible. I'm really sorry. But you'll notice we get two entirely different answers. So please don't think the answers are like always, like this is like the standard algebra 1 answer. X always equals 9 and negative 9, always. And so in algebra 1, there I would always get answers like x equals plus or minus 17 halves, always. That's not how it works. So you can check these things. All of your calculators you can evaluate. They have absolute value on them if you wanted to check your answer. On the Casio, you get to press option, and you get a bunch of options. And if you arrow over a little more under num is number, and there's ABS, absolute value. It's not anti-lock braking system, it's absolute value. So the absolute value of 2 times, negative 11 halves minus 3. And what's it supposed to equal? There it is. And it does equal 14. And you can plug it in. If you have a TI, then it's under the math menu. Math, num, ABS. Okay? Yes, there are only 2 answers.
Is there a point where it does become plus or minus?
Not really, no. So again, I like to think about this the same kind of way, and this one is really, really weird. I'm going to focus on one side. So again, with my left side here. One equation is that left side was a positive. Value, and then by nature of the absolute value, it simplifies itself. And the other equation where that inside could have been negative, the negative result, and then it cleans itself up. Now, you'll notice I'm not doing, because there are 2 sets of absolute values, I'm not making both of them negative. If I make both of them negative, wouldn't they both be positive? Right? If you're negative on both the left and the right, wouldn't it just cancel itself out?
Mm-hmm.
Okay. So you just change one of them. All right. All right. So this is over here on the right. We just have this 2x minus 7 equals x plus 6. Easy to solve. So I'm going to subtract x. I'm going to add 7 and get x equals 13. Jack, you were going to ask me a question about your calculator?
Yeah.
The absolute value?
I got 17.
Okay, I'll check it in just a minute. And then over here, we can do a couple of things. Do you want to divide the negative or just distribute it? Just distribute. Yeah, that's negative 2x plus 7 equals x plus 6. I'm going to subtract the x. That gives me negative 3x. And I'm going to subtract 7, which gives me negative 1. And so I get x equals 1/3. Again, two entirely different answers, which of course you can check pretty easily just by plugging them back in. If you plug it back in, 2 times a third minus 7 is supposed to equal the absolute value of a third plus 6. Well, 2 times 1/3 is 2/3 minus 7. 2/3 minus 7? Negative 6 1/3? Sure.
Yeah.
Shouldn't the x plus 6 be a negative?
Okay, so here's what I was talking about before. I'm going to pick one and make it the opposite. Okay, if I were to change both of them, then I could divide by the negative and it'd cancel out over here, and so I'd end up with this equation. Does that make sense?
Yeah.
So you can actually make one or the other negative. It's not going to make a difference. Okay, pick one. Negative 6 1/3. What is the absolute value of negative 6 1/3?
6/3.
6 1/3. And over here, we've got the absolute value of 6 1/3, which is 6 1/3. So it does check out just fine. So you can check by hand too.
So is it going to be one or the other?
They'll both work.
Oh, good.
Yeah, so I could do this one as well. 2 times 13 minus 7 is supposed to equal the absolute value of 13 plus 6. 2 times 13 is 26. Minus 7 is 19. And the absolute value of 19 is 19. And over here we have the absolute value of 19, which is 19. So it does balance. Okay. So you can, not too bad, 2 equations. That's the key. 2 equations whenever you have an absolute value. And this is, I just always set them up this way. There's a positive one and a negative one. Okay. This is it right here. So example 2, solve the inequality and sketch the solution on the real number line and express the result using interval notation. A lot of directions. You can abbreviate those directions. Solve the inequality and express the result using interval notation. Solve the inequality and express the result using interval notation. So again, these are absolute value. So once again, because of the absolute value, there's going to be 2 equations. And just like we were doing before, there was a positive side and a negative side. The same thing applies here, but they have some different words in the middle. And I can't decide how I want to do this. So, but the first thing, you do divide the first thing by 5. Whatever we're going to do, we want to isolate the absolute value. So we want that absolute value all alone before we do anything. So yes, we want to divide by 5. That's going to give me the absolute value of negative 3 minus x is greater than or equal to 7. All right. So I need you to read this out loud to me. The absolute value of negative 3 minus x is, okay, right there. Greater than. is how you remember if this is an and equation or an or equation.
Love that.
This is an or equation, and that's really important. That means there's an or in the middle of our two equations, and this is a mathematical or, which means we're solving these two equations, and we can graph them on a number line, and there's going to be answers where one answer might work or the other answer will work, okay? So we're going to write our two equations just like we did before. We have the positive side equation where the inside was just positive is greater than or equal to 7. Or just like before, we had a negative side where we say, hey, that inside might have been a negative. So we create these two equations just like before, one that had the positive in front and one that has the negative out in front. Over here on the left, what am I going to do with that negative?
Distribute.
Or divide it.
Or divide it. Either one.
I distributed actually.
Okay, well, we can distribute. That's fine with me. All right. So negative times negative 3 gives me a positive 3. And negative times negative x gives me a positive x. It's greater than or equal to 7.
Shouldn't it be less?
Nope, because it exists. Right? Because it exists before. Is that how that works?
So if you had divided by the negative, then yes, we would have to flip the inequality and make that a negative. Watch, it'll happen.
Oh, I see.
Yeah, it's really interesting how it all works. And then I'm going to go ahead and subtract 3. So we get x is greater than or equal to 4. Or over here, I don't have to really do anything with that positive sign. We have negative 3 minus x is greater than or equal to 7. And what do we do to solve? Add 3. So we have negative x is greater than or equal to 10. And then divide by the negative 1. So what do we have to do when we multiply or divide by a negative? Flip that inequality symbol. So we get x is less than or equal to negative 10. So if I was going to graph this on a number line, I have negative 10 over here on the left. You see how they sort of flopped over. We want numbers greater than or equal to 4. Is that an open or closed dot? Closed dot. And numbers greater than or equal to 4 would be to the shade to the right. Good. And over here, this says we want numbers smaller or equal to negative 10. So open or closed dot. Closed dot at negative 10. And we want numbers littler than negative 10 to the left. All right, so then our interval notation. What are all the possible answers for x that will satisfy our original equation here?
Negative infinity to negative 10.
Negative infinity to negative 10 bracket union 4, yeah, good, 4 to infinity with closed bracket. All right, super. So I'm going to do it the same way for this other equation. So again, we want to isolate any absolute value. So what do we need to get rid of? Yeah, we're going to add 3 just first. Whoops. Add 3. So I get my absolute value, 2x minus 5 is less than 9. All right, read this absolute value inequality to me. The absolute value of?
2x minus 5.
Is less than.
Oh my god.
Is less than 9. So this is an and equation, and this is a mathematical and, okay? Mathematical and says whatever answer we get for x, it has to satisfy both equations. It must work for both, okay? In other words, we're looking for the overlapping region for our inequality, okay? It has to satisfy both inequalities. On this side, I could try 5 and 5 will work. If I tried negative 11, I could plug the negative 11 in and it would work. Okay, so we want to look for this overlap. I'm going to do the same way. I have a positive part equation. You'll notice I'm always going to put the positive one on, right? It doesn't technically matter when you do it this way, so that's kind of nice. Where the inside could have been positive, or my negative equation where that inside might have been a negative result. Now on this one, I'm going to show you, well, no, I'm going to let you decide. What do you want to do with our negative here? Divide by the negative? Sure, you can do that. And when you divide by the negative, what do you do to the inequality? You got to flip your inequality. So watch that. Be careful. So 2x minus 5 is greater than negative 9. And then what should we do? Add 5. So 2x is greater than negative 4. And then x is greater than negative 2. And there's an and in the middle. Do you see if you had distributed, you would still get the same result? You would save the flipping till the end, but you'd still get the same result. Over here, my positive doesn't do anything really to me. So I have 2x minus 5 is less than 9. And what do we need to do? Add 5. So 2x is less than 14. And then x is less than 7. So if I was going to graph these on a number line, I have negative 2 and 7. At negative 2, is it open or closed up?
Open.
Open. And we want numbers greater than, so that would be shade to the right. And that goes on forever, right?
Yes.
Well, yeah, but, and on this side, we want numbers less than 7. So again, open circle at 7, and less than would be to the left. But the whole line isn't shaded. We only want this area in the middle where they overlap. So this technically doesn't go on. That one does go on forever, but with the and, we just want where they overlap. And so our interval notation would be from
Negative 2 to 7.
negative 2 to 7 in parentheses. Good. All right. So these symbols tell you if it's going to be an and equation or an or equation. Kind of interesting.
Wait, so if it's greater than it's or, and it's less than it's okay,
An and.
that's easy.
Yeah. So that's, I don't know that my teacher, he taught this to me, and I have never forgotten it. It was greater or less than, and it's just always stuck with me.
Well, what if there's absolute value on both sides?
There won't be.
Oh,
I don't think so.
So miss.
Otherwise,
Greater than have a
quit.
Right,
I mean,
so you
shut
do
up.
have to be a
You
little
don't know
tricky.
English.
But it's great
Great
tour.
English,
So yes. So focus
I
on the
can't
tour
spell.
part.
Either.
All right, ladies and gentlemen, there you go.